Hi, Mr. Luong. This is my FRQ2. So for part A, I'm going to label the axes first. So the X and Y. The Y-axis is going to be T. And then the X-axis, the X-axis is T. And then the Y-axis is going to be the force. I'm going to do it by 100. And then for 1 to 5. Okay, just gonna plot them. Okay, and draw like a best fit line. Okay, that's not straight. Okay, that is straight enough. And then using the graph, I can determine an expression for f of t. So f of t, and then equals, basically I'm gonna use slope formula. So then the slope of this is going to be 100 minus 80 over 1, so that's like negative 20 t. And initially the force is 100, so it's going to be that for the function. And for acceleration, I know f of t can be expanded to ma of t equals to negative 20t plus 100, and then m is going to be 5, so then I just divide 5 to both sides, and then acceleration is going to be negative 4t plus 20. That is the function expression for at. And then to sketch that, I'm going to make this and this, and then the x-axis is seconds, and then the y-axis is acceleration, and by 50, 40, 30, 20, 10, 1, 2, 3, 4, 5. And then it's going to start 20 and go down by 4, go down by 4, go down by 4, go down by 4, and then go down by 4. This is what the acceleration graph is going to look like. It's the best straight line I can draw. And then what information can be extracted from the acceleration versus time graph in part D. So I think what I can extract from this graph is finding the area under this graph will get me the velocity. So like I said before, finding the area under the graph is basically integration. So a of t is going to be integral, it's going to be v of t equals to integral of a of t. And then I can do v of t equals to integral of negative 4t plus 20. So that's going to be negative 4t squared over t plus 20t. And then since you didn't say anything about initial velocity and initial position, they're both going to be 0. So then v of t is going to be negative 2t squared plus 20t. And that is, yeah, that's for part F. And then part G, using the information that can be extracted from A of t versus t graph in part E, determine V of 5. So V of 5, I think it's going to be, I can use the triangle formula. So where is it? Part G, yeah. So part G is going to be 1/2. Oh, v of 5. Wait, I gotta do v0 plus 0 to 5 from a of t dt. Oh, there's also dt there. Yes, okay. So since I said before, initial with velocity 0, it's going to be there. v5 is going to be 1/2 times 5, 1/2 times base times height. So 1/2, the base is 5, height is 20. So then, yes, acceleration is going to be 50. I mean, acceleration, velocity at 5 seconds is 50 meters per second. And for part H, I can just substitute in 5 for what I got for the velocity function. Okay, so you should get the same answer. It's 50 meters per second. And then for part I, I have to derive an expression for x of t. So deriving an expression for x of t is basically just like the a of t deriving expression for v of t before. You just integrate the velocity function. So x of t equals to integral of v of t. X of t equals to integral of, there's also dt, negative 2 plus 20 t dt. So x of t is going to be negative 2 cubed over 3 plus 20t squared 2. X of t is going to be negative 2/3 t cubed plus 10t squared. And then sketch the position versus time graph on for 0 to 5 second scale and label all axes including units. Okay, so I'm going to do x and t. 1, 2, 3, 4, 5. I think I'm gonna do this by 40, 80, 120, 160, 200. So then all the values, when you plug it in back into the x function, so for the x at 1 second, I got like 9.33, which I think should probably be down here. And the next one for x of 2 is going to be 34.67 when you plug it back into the equation. So it should probably be somewhere around there. And then for x of 3, I got 72. I think should be somewhere around here as well, I guess. And then x of 4 is 117.33. So it's going to be like somewhere around there as well. And x of 5 is 166. Somewhere around there. So this is the position versus time graph. And then I have to draw a line that represents the instantaneous velocity at t equals 2 seconds. So I'm going to make this a different color, like blue. So 2 seconds, the velocity will look like that. Instantaneous velocity will look like that. And then draw a line that represents the average speed between 0 to 1. So I think it's going to look somewhere around like that. Yeah, you just like Oh, initial velocity is 0, so yeah. It's gonna look like somewhere around there. And then 0 to 2 is just gonna be like that. 0 to 3, 0 to 4, 0 to and then 0 to 5. And then the average speed of the cart from 0 to 5 is the greatest because it covers the most distance over a greater time, but it's also steeper, so that means that it's greater. And then for average velocity between 1 and 3, I can let's change it back. I can use the graph, the points at the graph I got, to solve for average velocity. So final position at 3 seconds was 72. Final position at initial position at 1 second was 9.33 over 2 seconds equals to 31.33 meters per second. That's all.